I'm now going to start part 2 of the homework problems for the chain rule. And for part 2 of this video, we will start on questions that have to do with finding the equation of the tangent line to this particular function here when x equals to 1. Alright, so when you have a tangent line problem, I would go ahead and write out the equation of the tangent line, which is y minus y1 equals to m times x minus x1. So let's go ahead and write out the equation there. And then we're given x equals to 1. So this is kind of like your x1 in your formula. Let's go ahead and find the y value when x equals to 1 by substituting 1 for all the x values. So if I substitute a 1 there, 3 times 1 is going to be 3 minus 2 all squared. So that will be 2 divided by 1 squared, so that equals to 2. So my point is 1 comma 2. So this is my x value and that's my y value. And now let's go ahead and update my tangent line equation here by plugging in the values of y and the values of x, the value of x there. Okay, so that takes care of that. Let's go ahead and now we need to find the slope, which is the m value. And in order to find the slope, in order to find this m value here, we have to take the derivative. So if I go ahead and take a look at this problem here, I need to take the derivative by using the quotient rule. So the quotient rule states that you take the bottom and you rewrite that on the numerator as 3x minus 2 all squared. And then you take the derivative of the numerator, and the derivative of 2 is 0. And then the quotient rule states that there's a minus sign, and then you can write out the numerator as 2. And then you need to write out the derivative of the denominator. In this case, this 2 here would come out in front, so that would be 2 times 3x minus 2 to the power 1. And then the chain rule states that you need to take the derivative of the inside term, which will be 3 in this case. Okay, and then the quotient rule then states that you take the denominator and then you square it. But since there's a 2 already on the denominator, sorry, let me just erase this now. I was just saying that since there's a 2 there, and if you square that, you should get a power of 4 there. Okay, so let's go ahead and simplify this problem as much as we can here. I mean, so this guy goes to 0, and then if I take this 2, that 2, and that 3, if I multiply all that, I would get negative 12. So negative 12 times 3x minus 2 to the power 1 all over 3x minus 2 to the power of 4. So this is y prime. And if you want, you'll notice that, I mean, essentially I can also cancel this guy off with one of those guys, giving me a 3 there. So if I went ahead and kept on simplifying here, I would get negative 12 over 3x minus 2 to the power of 3. And this is y prime equals. Now I need to find the derivative value when x equals to 1. So now I need to evaluate f prime of 1. This will tell me my value of m now. So anytime you see an x, that's going to be replaced with the 1 there. So if I keep on continuing here, it would be negative 12 divided by, well, 3 times 1 is 3, and then 3 minus 2 will essentially be 1. So this will be negative 12 over 1 cubed, which is just negative 12. Okay, so if I take this negative 12 and if I go back to my tangent line, I need to now, rewrite my final answer here. So my slope value had a value of negative 12, and then I have x minus 1, and that would be my final answer for the equation of the tangent line for that particular problem. Okay, let's move on to question number 2 here. Find the equation of the normal line to the curve. So I have a normal line, this is my curve, and my x value here is x equals to 2. Alright, so step number 1, I would go ahead and write out the equation of the tangent line, because the tangent line and the normal line, they are related. You just need to do one extra step at the very end. And if your x value here is 2, let's go ahead and find the y value when x equals to 2. So anytime you see an x like here and here, you want to replace that with 2. So that's going to be 2 times the square root. Now 2 squared is going to be 4, so 4 minus 3. So that will equal to 2 times the square root of 1, which is going to be 2. So f of 2 equals to 2, and my coordinate is now 2, 2. So this is my x value, and that is my y value. So if I go ahead and just update my formula here, my tangent line, I can go ahead and write minus 2 and minus 2 for the x and y values. Alright, so just like the previous problem, I need to now find the value of m. So m is the derivative value or the slope, and in order to do that, I need to find the derivative here. So before I take the derivative, I'm going to rewrite this problem as x times bracket x squared minus 3. I'm going to change the radical into a power, and the power will be 1/2. Now it's ready for me to take the derivative. So in order for me to take the derivative, I need to use the product rule first. So the derivative of x is 1, and then the product rule states that you just keep the second term as is. And then the product rule states that you need a plus, and then you need to multiply the first term times the derivative of the second term. Now, if I take the derivative of the second term, I have to use the power rule first, so the 1/2 comes in front, and then I would write the x squared minus 3, and then I need to subtract 1 on the power there, so 1/2 minus 2 over 2 is negative 1/2. And then you would take the derivative of the inside, and the derivative of the inside there is going to be 2x, and then I would close the bracket there. Okay, so if you want to simplify this, I mean, you could, y prime would equal to 1 over the square root of x squared minus 3 plus, okay, so this 2 and that 2 will cancel off. So that cancels off, that cancels off. X times x is going to be x squared divided by the square root of x squared minus 3. Okay, so quite a bit going on over there. Actually, I realized that I made a mistake here. I apologize. Sorry, I thought this was supposed to be x to the power negative 1/2, but it's actually just a 1/2. So sorry about that. I'm going to erase this now. This is going to be the square root of x squared minus 3. Okay, so sorry about that small mistake there. Alright, so there's my derivative, and I need to find the derivative when x equals to 2, right? Because that's the x value that's given to me. So I can erase this the y prime and write f prime of 2, right? So I want to find the derivative value when x equals to 2. So now all I have to do is take my 2 and plug that in for all my x values, and then I should be able to find the slope value finally. And in order to do that, let's go ahead and do this. So 2 squared is 4, so that would be 4 minus 3 plus. If I plug in 2 over here, 2 squared would be 4 divided by the square root of, if I plug in 2 over here, 2 squared is once again 4 minus 3. And we do actually get a nice expression that kind of works out here. This will be 1 plus 4, which equals to 5. So my slope value equals to 5, but the slope that's normal to the line is going to be negative 1 over 5. Okay. All right, so with that, I can go back and update my tangent line here. So my tangent line answer would be y minus 2 equals to negative 1 over 5 times x minus 2. That is my final answer for that problem. Okay, let's move on to the next one here. Example number 10. At which points does the function have the tangent line parallel to the line x plus 2y equals to 6? Okay, so there's a lot going on in this problem, and before we actually start attacking the problem, we should try to figure out what this problem is asking us to do with the visual diagram here. So I'm going to take this linear line right here, and I'm going to rewrite that in terms of y. So that would be 2y equals to negative x plus 6. and then I can divide both sides of the equation by 2. If I do that, I get y equals to negative 1 over 2x plus 3. Okay, so what I would like to do now is I'm going to take this guy right here, and I'm going to take that guy right there, and I want to do a very light sketch on the side here to kind of figure out what the hell is going on in this problem. Okay, so if I look at this problem here, I do have a vertical asymptote at, okay, so if I take 2x plus 1, set that equal to 0, 2x equals to negative 1, x equals to negative 1/2. So when I'm at negative 1/2, I do have a vertical asymptote. And if I try to kind of sketch a little diagram of 1 over 2x plus 1 all squared, perhaps it kind of looks something like that, like this. Maybe something like that, perhaps. And then if I graph the linear line, the negative 1/2 x plus 3, maybe the problem kind of looks something like, whoops. Sorry, some technical difficulties there. Maybe it kind of looks like that. So this is y equals to negative 1/2 x plus 3. Okay, so if I graph both of the equations using like a Desmos or your graphing calculator, perhaps the problem kind of looks like that. All right, so what we need to do is we need to go ahead and find a point on the blue graph, because the question is asking for a point, and that point has to be parallel to the function, right? So if I put a red dot here, and if I drew like another line right here, I mean, this red line is definitely parallel to that green line, and the question is just asking what is this particular what are the points right at that dot right there, because at that dot the red line is parallel to the green line. Okay, so that's what's happening like visually in this problem. So what we're going to have to do is, if I think about the blue equation here, I need to take its derivative. Whoops. Sorry, I need to, So the blue line there, so basically what we're doing is we're going to have to take its derivative. And then we want the derivative to be equal to the slope of this green line, which is going to be negative 1/2, and that will allow us to find the x values where the blue graph has a slope of negative 1/2. Okay, so I'm not sure if that made like a total sense there, so we're gonna slowly have to do this one step at a time, and hopefully we will be able to make some connections here. Okay, so if I go ahead and take the derivative of this expression, I'm going to rewrite that as y equals to bracket 2x plus 1 all to the power of negative 2. All right, so if I write the expression like that, then I can take its derivative pretty easily. So this will be negative 2 times 2x plus 1 all to the power of negative 3. And then I would now take the derivative of the inside guy, which is, the derivative of 2x plus 1 is going to be 2. All right, and then, after that, then we can continue to simplify this. So this will be y prime equals to, well, 2 times 2 would be 2, and the negative sign would tag along, all over 2x plus 1 all cubed. All right, so that is my derivative. And what we're going to do now is, sorry, I'm going to try my best to explain this very slowly here. This is my derivative right here, and I want my derivative to be parallel to, it has to be parallel to this linear line. And if you're parallel, that means the two lines must have the same slope. Okay, so since this linear line has a slope of negative 1/2, I want to make my derivative equal to negative 1/2. All right, so if I set my derivative equals to negative 1/2, then what I'm doing now is I'm trying to find all the x values on that blue graph where we have a slope of negative 1/2, because that would make it parallel to the green line, which is the linear line for this problem. Okay, so essentially now we need to solve this expression right here in this red box. Find the x values so that the left hand side equals to negative 1/2. Alright, so in order to solve this problem here, I'm going to highlight this blue guy and I'm going to just multiply it with the negative 1. So that will give me negative bracket 2x plus 1 to the power of 3. And then I'm going to take this 2 and I will multiply with the negative 4, and that will give me negative 8. Okay, you'll notice that the minus signs can now, they can just cancel off now. And I can take the cube root of this side. And if I take the cube root of that side, I'm left with 2x plus 1. And if I take the cube root of this side, I get 2. And then I can minus 1 on each side. So that would give me 1 on this side, and now we get a 2x there. And then I can divide both sides by 2. And that would mean that x would equal to 1/2. So 1/2 is one of the x values. And in order to find the y value, I would go back to the original problem here. So I'm going to erase all this. I need to evaluate f of 1/2 by plugging in 1/2 into the original problem. So this would be 2 times 1/2 plus 1 all squared. So tons of work for this particular problem here, and I'll notice that these guys will cancel off. So that would give me 1 over 1 plus 1 all squared, which will give me 1 over 2 squared, which equals to 1 over 4. So what that means is the x value on the graph that was highlighted in blue earlier, the coordinate 1/2, 1 over 4, this point right there is the point where the blue graph has a slope of negative 1/2, which will make it parallel to the equation of the green line. So this will be 1/2 and 1/4. Okay, so the blue graph, so once again, on the blue graph, the point 1/2, 1 over 4, that's the point where this line right here, which I'm highlighting in green, that's where the blue graph has a slope of negative 1/2, which matches the slope of negative 1/2 on the linear line, and that makes it parallel. Okay, so I said quite a bit in that problem. Watch this, go back and watch the problem a few more times if you didn't quite get it, or please come see me in class. Okay, I'm going to move on to some more derivative questions. This time we're dealing with composite functions. Alright, so I'll go very slowly with these problems as well. So I want to take the